Hello students, welcome to e-physics class presented by Fatima Convent High School, myself Dipali. Chapter 10, Light, Reflection and Refraction. Let us understand the next topic of this chapter, that is magnification by spherical mirrors. Now we have understood very clearly that what are sign conventions and how are they applied to the various parameters of the mirrors. Now let us still get an revision view of this sign conventions. Now we know that we are going to talk about these quantities related to the mirror, that is u, which is object distance, v, image distance, f, focal length, r, radius of curvature, h, object height, h prime, image height, and p, power. Power we will understand in the last part of the chapter. Yet, now let us see what sign conventions are given to these parameters. Now we take a concave mirror first. Now you can observe that if I place a concave mirror on a coordinate plane and pole being the origin of the coordinate axes, we understood the rule that the measurement of object height, image height, object distance, image distance, focal length and radius of curvature is taken from pole. So think P to be the zero of your ruler. Now suppose if you want to measure the object distance, that is u, as our object is placed here beyond C, then you will take here 0 and you will start measuring till here this point. Now this point will have what type of magnification or magnitude? Positive or negative? We know that this is negative x-axis. So it will have negative sign. So it will be minus. Same way, if I measure the image distance, that is v, will also be negative, but only in one case when the image is formed in the virtual, that is behind the mirror and erect. That time your v will be positive. Now we talk about f, focal length. Then if we measure from here to here, it will be negative. Radius of curvature, that is from this point to this point, which is also measured this way, so it will be negative. Now image and object height. Object height is measured towards the positive y-axis, so it will be positive, and the image height is measured towards the negative y-axis, so it will be negative. Did you understand how simple it is? Now you can observe here that the object height, object distance in the concave mirror will be always negative. Image distance will be negative in all the cases except for one. Focal length will be negative, radius of curvature will be negative, object height will be positive, and the image height will be negative. But in case of erect image, it will be positive. And power, which is 1 upon f, will be negative. Did you understand how the sign conventions are given? Now let us see about a convex mirror. We know that for a convex mirror, C is the part of the sphere from which the mirror is taken, but focal length is not the part, it is behind the mirror, it is not inside it. So if we start measuring the focal length the object distance and the image distance, then focal length will be positive, object distance u will be positive, image distance will be positive, focal length positive, radius of curvature will be negative, object height will be positive, image height will also be positive. So, you can understand that when the image is virtual and erect, the object height is always positive, and when the image is real and inverted, the object height is negative. So, is this very much clear to you? We can see now that for a convex mirror, the object distance is negative, the image distance is positive, focal length is positive, radius of curvature is negative, object height is positive, image height is positive, and power is positive. This is very important for solving the various numericals. Now, let us see how this is related to magnification and mirror formula. Now, in a spherical mirror, the distance of the object from its pole is called the distance, object distance, that is u. The distance of image from the pole of the mirror is called image distance v. We have already known that the distance of the principal focus from the pole is called focal length f. There is a relationship between all the three quantities, and this relationship is called as the mirror formula, which is expressed in case of a mirror as 1 upon v plus 1 upon u is equal to 1 upon f. This formula is valid in all situations for a spherical mirror for all positions of the object. You must use the new Cartesian convention while substituting numerical values of u, v, f and r in the mirror formula for solving the problems that we have already understood how it is supposed to be. Now, let us see what is magnification. Magnification produced by a spherical mirror gives the relative extent to which the image of an object is magnified with the respect to the object size. So, whether it has become larger, but how much larger will be known by the magnification value. It is expressed as the ratio of height of the image of the object to the height of the object. It is usually represented by the letter m. If h is the height of the object and h prime is the height of the image, then the magnification m produced by spherical mirror is given by m is equal to height of image h prime upon height of object h. M is equal to h prime upon h. The magnification m is also related to the object distance u and image distance v. It can be expressed as magnification is equal to h prime upon h is equal to minus v by u. You may note that the height of the object is taken to be positive as the object is usually placed above the principal axis, and the height of the image should be taken as positive for virtual image. Very important to understand. However, it will be negative in case of real image. The negative sign in the value of magnified indicates that the image is real. The positive sign of the value of magnification indicates that the image is virtual. I hope this is very much clear. Then we can solve a numerical based on this. A convex mirror used by a rear view on an automobile has a radius of curvature 3 meters. If a bus is located at 5 meters from this mirror, find the position, nature and size of the image. Now we know that the radius of curvature is given as r. Now first of all, try to identify which type of a mirror it is, a convex mirror. In convex mirror, the radius of curvature is taken positive or negative. We know that we can measure it as plus. So, R is equal to plus 3. Object distance U is equal to minus 5. Image distance V we are supposed to find, and height of object H prime. Now focal length F is equal to R upon 2 is equal to 3 upon 2, that is 1.5. A convex mirror is behind the mirror. So, the principal focus in the convex mirror is behind the mirror, and so 1 upon U plus 1 upon V is equal to 1 upon F, or 1 upon U is equal to 1 upon F minus 1 upon U is equal to plus 1 upon 1.5 minus 1 upon minus 5 is equal to 1 upon 1.5 plus 1 upon 5, that is 5 plus 1.5 upon 7.5. So, V is equal to 7.5 and 6.5 is equal to 1.15. So, the image is 1.15 meters at the back of the mirror. Magnification M is equal to H prime upon H is equal to minus V upon U, that is equal to minus 1.15 upon minus 5. So, the negative value, the image is virtual, is positive 0. The magnification we are getting is plus 0.23. So, if it is positive, means the image is virtual, erect and smaller in size by the factor of 0.3, because if the image is equal to, now if you get, there are three possibilities of getting the magnitude of any magnification, that is M can be equal to 1, M can be less than 1, M can be greater than 1. What does this mean? Now, when is M 1? M can be 1 when H prime upon H is H prime is equal to H, then M is equal to 1. This means object height and image height is same. Now, when I say M is less than 1, which means that my image height and object height should be in what ratio? H prime upon H, which will be greater, which will give you less than 1. We know that when it is, for an example here, we have 1.15 upon minus 5, that is your V by U, that is plus 0.23. Now, you can see that image height is 1.15 and object height is 5, that is the object is larger and the image is smaller. So, magnification we got less than 1. So, if the object height is greater and the image height is smaller, we get M less than 1. So, the size of the image will be smaller. And when is M greater than 1? When H, here H prime will be less than H. Here M upon H, where H prime will be greater than H. Then we get greater than 1. So, it is an enlarged image. So, we can say that from the comparison with 1, we can know the height of the object greater or smaller, that is the size of the object can be known from the value of M, magnitude of M, and positive and negative sign of M denotes whether it is a real or a virtual image. So, from magnification we can get the characteristics of any image. Let us do one more example. An object 4.4 centimeter in size is placed at 25.0 centimeter in front of a concave mirror of focal length 15 centimeter. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and size of the image. Now we are talking about a concave mirror here. So the focal length, first we take the object height is +4, object distance is -25, focal length is -15, image height distance we have to find, and image size h prime we have to find. Now we know the formula 1 upon v plus 1 upon u is equal to 1 upon f. If I replace the value, I get the value of v as -37.5. The screen should be placed at 37.5 centimeter in front of the mirror. The image is real as it shows the negative sign. Same way, magnification m is equal to h prime upon h is equal to minus v upon u, or h prime is equal to minus u v upon h into h upon u is equal to, on solving, h prime is minus 6.06 centimeter. So the image is inverted as it is negative and enlarged as it is greater than 1. So this shows us how magnification of a mirror can be obtained and how mirror formula is applied.